In lesson 7.2, we start with properties of proportions. A lot of you know properties of proportions have to do with how two ratios are equivalent. So our job today is to solve for an unknown term or express the proportion in an equivalent form. So in geometry, we use terms like means and extremes. And if we were taught back when we first learned about ratios and proportions, that these two terms, A and D, would be known as the extremes, and B and C would be known as the means, I don't know that we would have actually understood exactly what was going on. However, now that we're going to start talking about this in a more geometric sense, means and extremes property is what we would call it. And so when the two ratios are equivalent, we're going to start talking about what that proportion would look like. If you're using it in a proof and you want to ensure that the ratio of A to B is equal to the ratio of C to D somehow, you can just simply state the property of proportions exists. There are 5 properties of proportions. The product of the means is equal to the product of the extremes. This is called the means extremes property. The one thing that we would call this normally is a cross product or a cross multiplying, where 2 times 6 equals 4 times 3. Working with that setup of means and extremes in the locations that they are, you can then create an equivalent proportion by interchanging the two means, where 3 and 4 switch to 4 and 3, and now 2/3 equals 4/6, but still 2 times 6 is 12 and 4 times 3 is 12, no matter how you arrange them. You could also do the reciprocals of that, where the means and extremes then flip positions, and now you have 4 halves equals 6/3, 4 times 3 is still 12, and 6 times 2 is still 12. One that we may not have seen is that if you add the number 1 to both sides, your proportion is still the same. And the reason we could do that is because the common denominator in this ratio is 4, so 4 plus 2 is 6. Keeping the denominator of 4, we have 6/4. In this fraction, we have 6 as the denominator, so 6 over 6 is our fraction. 3 plus 6 is 9. We then multiply 6 times 6 as our means extremes, and 9 times 4, and get 36 for both. Again, if we extend a proportion more than just two ratios, the sum of all the numerators to the sum of all denominators as a ratio are equivalent. It's not in the correct order, but if you do add and extend 2 plus 4, you get 6, and 2 plus 1 in the numerators, you get 3. You could continue to extend this out to 8 over 16. You could do 50 over 100, and they would still add up if you had an extended proportion. In the next couple of examples, try not to look at your worksheet as they are examples that are on the sheet, but we're going to go through them so that you can see. Complete the following statement. If the ratio of x to 4 equals 3 to 7, then 7x equals what? Well, it's not set up necessarily as a proportion because we're used to seeing them as fractions, but you can still set it up so that x over 4 equals 3 to 7, and when you cross multiply, 7x equals 12, and therefore there's your answer. In the next one, if 3 over x equals 5 to y, what's the ratio of x to y? Well, somehow we have to get x into the numerator of the other fraction, or at least be able to tell where it belongs in order to figure that out. When we multiply both sides by x and then multiply the other side by 1/5, you get the ratio of 3/5 equals x to y. You could also just interchange the means there. Take a second, hit pause, and answer questions 1 through 6 on your sheet now. Again, try not to look at your sheet for this example. It is example 2. Which example or which equation is equivalent to 3/4 equals x over y? Is it 3x equals 4y, or is it 7/4 equals x plus y over y? which one would it be? Hopefully you saw that even though x to y wouldn't work because you would have the opposite, you would have x to y would equal 4 to 3, the ratio over here simply just adds 1 in the form of 4 over 4 on the left and y over y on the right. If you equate that to this proportion over here, they're the same, just in a different form. Take a second and answer question number 7, A, B, C, and D now. Here's question number 7, and hopefully you selected the following answers as your equivalent proportions to A over 7 equals 4 to 21. A, B, C, and D all equal the same proportion as the one given above. The next example is example 3. Try not to look at your sheet and answer for x as you would use the means extremes property and some algebra in order to solve for x. The answer for x in number 5 would be 7.5. The answer for number 6 is 12 2/3. And the answer for number 7 is 7. Hit pause and answer questions 8 through 17 now on your sheet. The final example is example 4. Again, try not to look at the sheet. If the ratio of AD to DC equals AB to BC and the given information of AC being 18, AB equal 12, and BC equaling 15, your job is to find AD and DC. In the solution, hopefully you said that AD was x, then DC would be 18 minus x. Since we know the ratio of 12 to 15 from the given information and the ratio above, we could then simplify that to 4/5. Given that the ratio of x and 18 minus x is the same as 4 to 5, we can cross multiply and solve to find that AD and DC are equal to 8 and 10. Finish up with numbers 18 through 20 by filling in the chart and bring that in for homework tomorrow.